Just take a look at this video. It's from China, and China is literally sinking into the ground, and at the same time, there's massive flooding. Cars and people are being swept away by fast-moving rivers that are swallowing major cities. Seriously, China is literally sinking into the sea, flooding and sinking far below sea level. Many of its cities will disappear, and this is no surprise to me because I've seen it. About half of China's urban areas, representing 29% of the country's population, are sinking. That's about 270 million people living on sinking land, but it's not just sinking, it's literally swallowing itself. China has a huge problem with sinkholes that basically swallow people, cars, and really anything that gets in their way. These giant holes open up in the middle of cities and swallow everything above them. Poor urban planning and the improper sizing of the buildings China is building to impress the world means that the holes open up and swallow everything that shouldn't have been there in the first place. I've seen sinkholes open up in sidewalks, streets, and everywhere in cities all across China. I've seen lots of footage of this happening. And let me tell you, this is not a problem that's getting better. It's only getting worse. Have you ever wondered why some of China's most iconic skyscrapers are sinking? Today, we'll analyze the reasons behind this catastrophic phenomenon. The biggest reason behind the collapse of buildings in China is China's progress. These huge structures put a lot of pressure on the ground, causing the ground to gradually subside. In this video, we will show the other face of China in which the progress made by China is harming China today. China contributed almost half of the world's total urbanization in the first 15 years of the 21st century. With a rapid pace of construction of housing, airports, roads, and water supply, ABC report has pointed out, China is adding about 21.5 billion square feet of space to its cities every year. Construction on this scale requires sand, gravel, water, and cement. A study shows that China still makes up about half of the world's total annual 4.1 billion tons of cement production, 52%, followed by India 6.2%, the EU 5.3%, and the US 1.9%. Due to such high use of concrete in China, at least 640 cities have increased the risk of heavy rain events. In 2021, an extreme rain event in the inland city of Sinkholes, more than 300 people died in the incident. Land subsidence can damage the city's infrastructure and endanger the public, and the process of subsidence is irreversible, says a 2012 report. It found that the sheer weight of the concrete, glass, and steel in the city's skyscrapers, an estimated 762 million tons, is contributing to the subsidence of the ground they're built on. China used as much cement in 3 years as the US did in the entire 20th century. China's use of so much concrete and cement is now leading to its destruction. Recent studies by Beijing University and the Chinese Academy of Sciences paint a stark picture of urban China within 100 years. About 26% of its area could go underwater. It has been reported that China's major cities are sinking by more than 10 millimeters annually, which, if the trend continues, could displace significant populations and damage national infrastructure. Experts blame excessive use of groundwater and the weight of rapidly building skyscrapers for this sinking. During the first 15 years of the 21st century, China created almost half of the world's total urbanization. Housing, airports, roads, water supply, waste treatment, power stations, and more have been built at an astonishing pace. In one instance, during the COVID-19 pandemic, Chinese officials claim to have built a new hospital in just 10 days. China is adding about 2 billion square meters, 21.5 billion square feet of floor space to its cities every year, the equivalent of building an urban area the size of London. Decarbonizing concrete would actually lead to meaningful reductions in greenhouse gas emissions. Although estimates vary, the International Energy Agency has found that the cement industry is responsible for about 7% of human-caused CO2 emissions worldwide. Concrete is the second most used material in the world after water. Savory says water use is also inflated in this ranking because it is used to make concrete. The authors of a paper published in the journal Science found that 45% of China's urban land is sinking faster than 3 millimeters per year, and 16% is sinking at more than 10 millimeters per year, causing not only falling water levels but also a heavy burden on the built environment. The team of researchers led by Ao Surui of South China Normal University said that with China's urban population already exceeding 900 million, even a small amount of land subsidence in China can pose a major threat to urban life. China is already losing more than 7.5 billion yuan, $1.04 billion a year to land subsidence, and about a quarter of coastal land could actually be below sea level in the next century, putting hundreds of millions of people at even greater risk of submergence. It makes it clear that this is a national problem for China, not just a problem in one or two places, said Robert Nichols of the Tyndall Center for Climate Change Research at the University of East Anglia. And it's a microcosm of what's happening in the rest of the world. The northern city of Tianjin, with a population of more than 15 million, is believed to be one of the worst hit. Last year, 3,000 residents were evacuated after a sudden geological disaster that investigators blamed on a lack of water, as well as the construction of geothermal wells. Many of China's old coal fields have also suffered from overmining, with authorities often forced to pour concrete into crumbling shafts to consolidate the ground. The problem is not limited to China. A separate study published in the journal said about 6.3 million square miles of land is at risk worldwide. Indonesia is among the countries worst hit, with large parts of the capital Jakarta now below sea level. Nichols said lessons should be taken from Tokyo's sagging cities, which sank by about 5 meters in the 1970s after restrictions on builders. A lot of choice has to be made about stopping land sinking, but you can't stop it completely, so you're talking about adapting and building bonds, he said. According to a 2022 Singapore study, 30 of the 44 major cities suffering the problem are in Asia. The problem is not just due to land mismanagement, it is also connected to other sectors. China's reliance on coal and the boom in its semiconductor and AI industries are increasing water consumption. Facilities, especially data centers, that cool the enormous heat generated by AI systems are further exacerbating China's water problems. It has been estimated that Chinese data centers could consume more water than a country like South Korea uses by 2030, putting even more pressure on already limited water resources. More water used means less water in rivers and in the ground, due to which heavy building on already subsiding land is happening more rapidly. But what is the role of AI in the semiconductor industry in increasing subsidence? Recently, China has started using more water due to the production of semiconductors in its country. After that, you may not know how much water is used to make your phone I present a cheapo, but did you know that it takes more than 3,000 gallons of water to make a single cell phone? The amount of water needed to mine the metal, make the glues and plastics for assembly and packaging, and then dilute the wastewater used throughout the process is 10 times more than the average daily water consumption per capita in China. Semiconductors, those tiny circuits called chips that power our electronic devices like phones, require a lot of water. To make the circuit boards that hold these chips, each of which is about 30 centimeters long, at least 2,000 gallons of water are needed. This water is used to clean the chips during manufacturing. They need ultra-pure water, which is as pure as industrial solvents, to wash away tiny particles and other debris left over from making the chips. To make 1,000 gallons of UPW, it takes 1,400 to 1,600 gallons of regular tap water. Acquiring enough semiconductors and building domestic production isn't China's only challenge. Ensuring there's enough water for semiconductor manufacturing can be even harder. China Water Risk estimates that a factory making 40,000 circuit boards requires 4.8 million gallons of water per day, enough for a city of 60,000 people. China has 20% of the world's population and only 7% of global water resources, yet faces water insecurity. Water distribution is uneven, with the north, where much of the semiconductor industry is based, having only a fifth of China's water. This is in stark contrast to the southwest, where there is more water but less semiconductor production. If you compare these two maps, you will see that there is a mismatch between the regions with the highest semiconductor production in the north and northwest of China and water availability in the regions below. China's semiconductor industry uses more water than Japan, South Korea, Taiwan, and the US, both for washing and power generation. China uses 3 times more water than the US. This industry alone consumes 27% of China's industrial water. Concerns about China's semiconductor ambitions must consider its water scarcity. Taiwan's 2021 drought showed how water shortages can hamper production despite technical prowess and skilled labor. In response, China has begun to enact policies aimed at curbing water use and is exploring innovative solutions such as submerging data centers in the sea near Hainan Island, a project that could save substantial amounts of power and water. In addition, new regulations that come into force and may encourage the development and wider application of water-saving technologies, boosting the market for innovation in water conservation. State broadcaster CCTV reported in 2012 that about 65% of domestic water in northern China comes from underground sources. Scientists say that in addition to groundwater use, the geological characteristics of individual cities also affect the speed of land sinking. Governments in cities most affected by land subsidence are taking various measures to slow the process, but often at a heavy price. In Shanghai, where the water table has dropped by more than 2.5 meters in some parts since the 1920s, more than 23 million cubic meters of water is being recharged each year through deep wells. To reduce Beijing's dependence on groundwater, China completed the South-North Water Diversion Project, a 4,350-kilometer network of canals and tunnels to deliver water to the capital. Some densely populated areas overseas, including Tokyo and California's Central Valley, also suffer from severe land subsidence. Expansive soils are common in China, particularly between 103° and 121° longitude. These soils are rich in clay minerals such as montmorillonite, which absorb water, causing the soil to swell when wet and shrink when dry. Particle size analysis shows that these soils contain a large amount of small particles smaller than 2 micrometers, indicating a high clay content. Many Chinese cities, including Shanghai, are built on soft, compressible soils such as clay and silt. The heavy weight of skyscrapers and other large buildings puts a lot of pressure on these weak soil foundations, causing land subsidence. This problem is prevalent in areas conducive to urban development, such as deltas and floodplains. which are common in China and other parts of Asia. However, these areas often have soft soils that are prone to subsidence under heavy loads. These soft soil properties can make them difficult to sample and test. Proper foundation engineering techniques are critical to supporting skyscrapers and other infrastructure on these weak soils. Urban planners and engineers need to consider the long-term effects of building on soft soils and use sustainable methods to reduce the risk of land subsidence. The combination of soft, compressible soil and the rapid construction of heavy skyscrapers is a major cause of land subsidence in many Chinese cities. Addressing this issue will require innovative foundation engineering solutions and sustainable urban development practices that consider the geological characteristics of the land. Poor urban planning has exacerbated the problem. In some cases, construction has occurred without adequate geological surveys or proper foundations, leading to instability. China's cities are growing fast, with many people moving in. To accommodate everyone, cities are quickly building tall buildings and other infrastructure. This rapid growth often happens without proper planning for water use or checking if the ground can support the new structures. About 300 million urban residents are seeing the ground sink beneath them because of this unchecked expansion. Many Chinese cities use a lot of groundwater to meet the needs of their growing populations. This overuse drains underground water sources faster than they can refill, creating empty spaces underground that cause the ground to sink. In cities like Chengdu, the land above subway construction areas is sinking more than 1 cm per year due to the weight of new buildings and the loss of groundwater. Urban planners often ignore the type of soil and its ability to support heavy buildings. Many cities are built on soft, compressible soils that can't hold up under the weight. This causes uneven sinking, damaging buildings, and increasing the risk of flooding. For example, some areas near roads in Beijing are sinking up to 45 mm each year due to heavy traffic and buildings. Building lots of infrastructure like subways and highways adds extra weight to the ground. In Shanghai, parts of the city have sunk more than 2.5 meters since the 1920s, mainly because of the weight of buildings and infrastructure combined with groundwater extraction. Sinking land can severely damage buildings, roads, and public transport systems, making them unsafe and costly to repair. Fixing these damages can strain local government budgets. Sinking cities are more prone to flooding, especially in coastal areas where rising sea levels add to the problem. Predictions suggest that a significant part of China's coastal land could be below sea level in the future, putting millions of people at risk. To reduce sinking, experts recommend adopting sustainable urban planning practices. This includes regulating groundwater use, improving water management systems, and considering geological factors in construction projects. For example, Tokyo has successfully reduced sinking by implementing strict water management policies, showing that proactive measures can work. Climate change and rising sea levels also play a role. Coastal cities are especially vulnerable as rising seas increase the risk of subsidence. Climate change and rising sea levels significantly impact coastal cities, increasing their vulnerability to subsidence and flooding. As the planet warms, sea levels rise due to two main factors: the thermal expansion of seawater and the melting of glaciers and ice sheets. By 2050, it's projected that sea levels in coastal areas could rise by 45 to 50 centimeters, worsening the flood risk for cities like Shanghai, which has already seen a rise of 115 m in the past 30 years. As sea levels climb, cities that are sinking face even greater challenges. The combination of land subsidence, where the ground slowly sinks, and rising sea levels can lead to more frequent and severe flooding. For instance, Shanghai is expected to experience flood levels much higher than current projections by 2030 and 2050. Without adaptation measures, catastrophic flooding could become common by the end of the century. Historically, cities like Shanghai have been sinking for over a century. From 1921 to 2007, Shanghai's subsidence averaged around 22.94 mm per year. Although the rate has somewhat stabilized, the ongoing rise in sea levels introduces new risks. Many Chinese cities are built on river deltas and soft soils, which are particularly susceptible to subsidence when heavy buildings are constructed and groundwater is extracted. This geological vulnerability amplifies the impact of rising sea levels as the land sinks while the sea rises, heightening the risk of local flooding. Looking ahead, studies predict that 22% to 26% of China's coastal land could be submerged by 2120, affecting millions of residents. The areas most at risk include densely populated urban centers already experiencing significant sinking. The economic and social consequences of this combined subsidence and sea level rise could be severe, threatening infrastructure, housing, and livelihoods. Without significant investment in flood defenses and better urban planning, large-scale displacement and economic losses are likely. Climate change and rising sea levels are escalating the risk of flooding in coastal cities, exacerbating existing subsidence issues. To mitigate these challenges, cities must invest in robust flood defenses and rethink urban planning. What do you think about this? Will China ever be able to solve this problem?